Okay, again, welcome. I'm Jane Wagner-Tyack, and I'm the Position Director and Legislative Analyst for Water for the California League of Women Voters. We've had a water team for many years, and for much of that time, we've been focused on environmental issues. We followed developments and monitored conditions in our really geographically and hydrologically very diverse state. And what we do is encourage civic engagement through action and advocacy on water. For much of that time, the kinds of weather disruptions we've seen in the last 3 or 4 years seemed pretty theoretical. The Water Interest Group is part of the California League's larger natural resources team, for which climate change is a dominant issue. The Intergovernmental Panel on Climate Change has estimated that the overwhelming majority of the impacts of climate change will be connected to water. So how well is California managing its water for all those who need it? To help us explore that question, we've been fortunate to have our Climate, Water, and Equity team, pioneered by Martha Davis, Ann Olmsted, and Inga Olson. Martha herself is well known in the larger world of water. She is a board member for the Mono Lake Committee and served as its executive director from 1983 to 1996. She's also the former assistant manager for policy development at the Inland Empire Utilities Agency. We're very pleased that Martha has invited Newsha Ajami to speak with us this evening. A few technical matters. I wanted you to know that chat has been disabled. Please put any questions you have in Q&A, and Martha will ask them after Newsha has finished her presentation. Now I'm going to turn this over to Martha to introduce Newsha.
Thank you so much, Jane. As Jane indicated, we all know the extreme conditions that we're grappling with, and this year is representative of it. In December, we were still in the worst drought in 1,300 years, and fast forward 4 months later, we're in the wettest winter in recent history. And now we hear predictions that we're looking at the summer, some of the highest temperatures that we might ever experience in California. So the question is, what's a water agency to do? And to lead us in the conversation, I'm honored to introduce our speaker, Dr. Newsha Ajami, who will offer her perspective for how water agencies can develop more cost-effective, affordable, and resilient water services by building water resilience from the bottom up. Newsha, I was trying to remember when I first met you. I know it was when you were a science and technology fellow for the California State Senate Natural Resources and Water Committee. You were working on water and energy legislation. What I can't remember is whether that was a decade ago or 2 decades ago. It was a while.
It was a long time ago.
It was quite a while. And since then, you have become an internationally recognized authority and leader in sustainable water management, smart cities, and the water energy food nexus. Dr. Ajami was the founding director of the Stanford Urban Water Policy Program and a senior research scholar at the Stanford Woods Institute for the Environment. And now Newsha is serving as the Chief Development Officer for Research for the prestigious Earth and Environmental Sciences Program at Lawrence Berkeley Laboratories. But what I think makes Newsha particularly special, perhaps unique, is that she's someone who practices what she preaches. She served as 2 terms for a governor appointee to the Bay Area Regional Water Quality Board, and she is currently the president of the San Francisco Public Water Utilities Commission, one of our state's largest water utilities. So thank you very much, Newsha, for being here, for offering your guidance. We look forward to your presentation.
Thank you so much, Martha, for that very kind introduction, and Jane for getting us oriented. I'm going to share my screen. I'm really delighted to be here. And I would just say, I would get the magazine of League of Women Voters when I was on the regional board, and I always looked forward to it. So it was definitely a highlight for me. Okay, let's share. I'm hoping that you can see my slides. Okay, perfect. Okay, fantastic. So I was tasked by Martha to talk about how to build water resilience. So I tried to put together some thoughts around some of the work we have done and what some of the things I've seen in practice on what to do and what not to do as we face all these challenges. Okay, there you go. This is, if you have seen me talking, I always use this slide, and I have a hard time not using it because it is so true. We certainly live in a world that's defined by 19th century laws. Think about our water rights system and the 20th century infrastructure. Think about all the dams and infrastructure that we have that move water around our state. And then 21st century challenges, impacts of climate change, wildfires, aging infrastructure, just name it. The way California was built was, very engineering focused. We have a state that is quite dry, especially when you go from the middle to south is quite dry, and we don't have a lot of water-rich areas. But our population, when they came here, they wanted to reside in nice coastal regions. And I was just recently watching a documentary about San Francisco's Hetch Hetchy project. And, every one of these stories, and, you can watch various documentaries about Southern California and its water sources. And in every one of those, you see that it was a city growing, but its growth was limited due to lack of water availability. And here come engineers trying to solve that problem by finding water source and trying to bring it to us and where we want to live. And a lot of the population growth that we see in California is driven by major engineering solutions and infrastructure that we have that moves water from the water-rich areas to the water less, more arid areas. And that's why we have one of the most complex water infrastructure systems actually in the world in many ways. So this legacy is something that we are dealing with, and that's overlaid by a lot of the water rights and generally water governance and laws that we have in the books. Now, the 20th century approach to water management was very much supply side. No one thought about how we can reduce demand. It was a little bit different. Not everybody had access to water. Not water wasn't coming out of everybody's faucet. The system wasn't fully built, so we didn't have a perfect understanding of how it works and how we can make it more efficient. And we also didn't really understand the unintended consequences of moving water from one location to another or one watershed to another. And we built a lot of these centralized, top-down, gray infrastructure heavy solutions that were based on abundance and climate stationarity. What I mean by climate stationarity is like, we assumed climate is going to repeat itself. We will have enough snow and rain every year for us to have enough reserve to be able to meet demand. And we created this sense of abundance that people can always have water as long as they open their faucet. So we disconnected people from their water source and created this very sophisticated system to regulate when and where water comes and how it's used. As part of this process, we forgot to think about, we basically left human behavior and environmental consequences outside of this cycle. We didn't really, again, as I said, we didn't really understand the environmental consequences of this solution, infrastructure that we built. And people were assumed to be just the consumer of the good, not necessarily involved in the decision-making process. This is very much present when you go out and potentially survey people. This is a study that was done by a researcher at University of Illinois, Urbana-Champaign, that basically asked a big group of people to draw out what their water system looks like. And what you can see is, yes, there are a handful of people who fall under A, that they know exactly where their water comes from and what happens to it and how it makes it to their tap. But there are a lot of people who actually really don't know what happens from rain to their shower. And or then what happens afterwards. People don't think about it. Sometimes people don't even know where their water is coming from, where it goes. They just know it's coming out of their tap. And this disconnect has definitely created a little bit of a problem. And also a lot of our water infrastructure is either hidden or it's outside of our service areas. So people really don't have a lot of appreciation for their water infrastructure compared to, let's say, roads or even electric infrastructure. So this water sector, this water system has worked pretty well for a long time. However, it is facing many modern challenges. As we just talked about, climate change, increased frequency and severity of extreme events. You're talking about not just droughts, but also floods and also wildfires, sea level rise. It's impacting our water infrastructure in so many different ways. Urbanization, 68% of the population is expected to live in urban areas by 2050. This is a challenge and an opportunity in many ways. But it's definitely is providing a challenge to modern model that we have. And we have aging infrastructure. A lot of the infrastructure that we have is man-made. They have a lifetime, and they're designed for a specific timeline. And many of them are reaching the end of their design life. And also competing environmental needs, because as we started operating these systems, we realized we are actually having significant impact on the environment. So we started sort of reacting to those impacts and putting together different regulations and creating more stricter regulations around how much water we take out of our water bodies and how do we use it. So those stricter regulations are impacting how much water we can take out of our systems and when and where and how much. And they are going to become even more more of these restrictions will be put in place as we are dealing with the impacts of climate change, because everybody is impacted by them, especially a lot of our ecosystem and species. And then on top of that, there's a lot of conversation around environmental justice, water access, affordability, the fact that many people are left behind. Right here in our backyard, in our state, there are people who don't have access to clean water, or they can't afford their water bills because the water is too expensive or is too polluted. When you think about water reliability equation, often, it's a very simple equation. There's water demand and there's water supply. And often water demand is assumed to be known and there. Population grows, so as demand grows, as we become more economically wealthy and there's more social well-being, there's more demand for water. That has always been a conventional assumption around demand, that it's very much directly related to population growth and social and economic growth. Therefore, as I mentioned earlier, a lot of our utilities have focused on water supply as a way of creating water reliability, trying to capture more water, finding other water sources, and trying to do more on the supply side. So majority of our focus have been on this side of this equation and not much on this side, unless we're dealing with a drought. Just going back here, I should also say our business model was also built that way. When you think about utilities, their business model also built around their job is to provide supply reliability. Therefore, they have to make sure they charge in a specific way that they meet demand. Now, when we think about that model, that demand is always perpetually growing, population is growing, therefore demand is growing, we constantly go back to that conventional model that we have in the 20th century. We need more reservoirs, we need big desalination plants, we need to bring water from other watersheds, we need pipes and pumps and dams and all these major large infrastructure, centralized infrastructure to create water reliability. Now, the question is this part of the equation that the demand is continuously growing is true, or does it work? Does the data reflect that assumption? This is just an example of one city in the US. Later, we'll talk about which city this is. The black line is one of the major cities. The black line shows the actual water demand over years, and all the dashed lines shows the demand forecast that has been done for this specific utility over the years. What you see is, imagine around the 1970s, their expectation of demand was by the 80s, they would need 260 million gallons of water per day, and therefore they have to develop that much water supplies. However, what happened was from the 70s till I mean, I don't have the rest of this graph right now here, but I promise you it's much lower than what it was even here. You can see that there's a gradual, first this becomes steady and then a gradual drop in water demand. And you can see that demand projections have always been quite off compared to where the demand actually was going. So we have not seen any demand growth in this specific city, despite the fact that our projections were quite, they were quite off and wrong in many ways. Now, we are talking about a future that's very different from today, right? We're expected to lose about 70% of our snowpack by the end of this century. And snowpack is naturally storing water for us and basically accounts for, again, another 70% of our total storage. This is like, a snowpack is great because we don't need to build anything to store that water. It basically sits on the mountain and basically gradually melts and comes down. So it's a very efficient natural storage that we have dependent on for many. Our whole system depends on it. Now, so when we talk about this drop in storage, we also need to constantly think, what does that mean when we are talking about demand, and how are we going to meet future demand as we are losing our snowpack, which is a natural storage that we depend on heavily, on our infrastructure for our current infrastructure model. This is another graph, again, produced by Pacific Institute, which shows the population growth, and demand change, water use in California, and the gross state products. In a way, it shows you economic growth, population growth, and water use in one graph. And what you see is since the 60s, our economy has grown by sixfold. However, and our population almost has doubled, but our water use has not changed. It actually had been quite steady over time. So that conventional wisdom that demand is growing is not really holding anymore. And that gives us an opportunity as we are losing our natural storage and our infrastructure is aging to kind of rethink how we want to develop our water supplies for the future. So as we're transitioning to this 21st century model or 21st century situation, the question is, what kind of an infrastructure model do we need and what kind of fresh thinking can we bring to this? So I'm going to provide you with a couple of ideas that kind of provide that bottom-up perspective that I think it's important when we are talking about the future. The first one is reducing baseline. I call demand our baseline because a lot of the people, a lot of utilities assume demand, whatever demand they're on, as a baseline based on which they're building future infrastructure or retiring old infrastructure they have. So we have to start from demand management as a first step toward building the future infrastructure. Now, I'm going to reveal this was the city of Seattle. And what we have seen over the years is water demand has decoupled from population and economic growth. And this is not what just Seattle experienced. This actually is true when you look at other cities across the US, San Diego, Washington, DC, Phoenix, different areas, different climate and different needs. But for all these utilities, demand has grown, population has grown, but demand has not changed. And we have noticed that we have always been off when it comes to predicting future demand, regardless of which utility we are looking at, because often what we use is population growth and economic growth as an indicator for demand change. And population has been growing and economy has been doing pretty well. So why is that happening? I'm sure you're asking, how is that even possible? Water use is quite complex and dynamic. The drivers have always assumed to be climate, economics, and demographics. However, there are emerging and understudied drivers that are impacting water use. that we are not accounting for in our demand forecasting process when it comes to utilities. There's a lot more public awareness around water. A lot of us have seen what happens, like, especially in the past 10, 20 years, California has been in more dry years than wet years. So we all read newspapers and hear the news. And there have been increasing public awareness around water and water scarcity and water and the challenges we are facing with our water supplies. So that has led to changes in behavior, partly also because every time we have put a restriction on water use, what we have seen is it doesn't bounce back. People embrace different solutions that because there have been a lot more awareness around this, that those solutions structurally changes their water use permanently. There have been a lot more urbanization. People are moving to urban areas, so they're denser, to dense cities. They have less outdoor spaces, so they use less water. There are also options for using recycled water for outdoor water use instead of using potable water that comes to our homes. One of the things I forgot to mention, and we're going to get to it, actually, I'm going to get to it later. Let's focus on this now. Recycling, as I said, has created, we are doing recycling in different forms and shapes in different scales right now, and that has definitely changed the amount of water we depend on. And a lot of this actually is hinged on this human behavior that I mentioned earlier has been left out of the equation when we were building our previous infrastructure. So human behavior is, in a way, disrupting our conventional model around demand forecasting, and is just providing these new drivers that's changing demand. Climate, as I said, demand is quite sensitive to many different things. I mentioned droughts and floods and fires, also economy, recessions can reduce demand. Also health, the pandemic really shifted the way people use water and where they use water. And we were not anticipating that. That was a huge shock to the system. But also there are policy shifts that has led into reduced water use. For example, our washing machines and dishwasher use a lot less water. The fixtures are much more, there have been a lot more technological advancement. We use less water in our fixtures, faucets and shower heads, toilets. A lot of changes in policy and codes and standards and technological advancements has led to reduction in water use. And the system still not fully saturated with those changes or those solutions. So there's still a lot of opportunity to embrace those changes as we are renewing our communities. Another way of reducing baseline, I mentioned this a couple of times, is reuse and recycling. So often when I talk about reuse and recycling, people think about a reuse, water reuse plant or water recycling plant down the street, a big one that can bring water through pepper pipes to your home, to your backyard, or potentially, ultimately one day we'll have potable reuse, which is one way to look at it. But there are so many other ways we can reuse water. And that goes back to reducing our baseline. And that's what I want to focus on here again. How do we use water in our homes? About 50% of that water is used outdoors, and the rest of it is used indoors. When you think about indoors, we are using about 30% of it in our toilets, 16% about 30% between faucets and showers. And the reason I picked on those two on the right side is because see how much they match. And where does your shower located? And where's your toilet? Right next to each other, right? So now I want to talk a little bit here about another flaw in our centralized system that we built. The way we built that thing was we treat water to the highest quality, put it in these pipes, and send it to people's homes. And they will use it for whatever purpose they want, but they are going to use that high quality water. At that time, somehow somebody thought flushing down toilets, drinkable water is a good idea. I'm not sure how good of an idea that is at this day and age, but we use a lot of resources and energy to treat that water. Some of that water is quite precious and important, and we don't want to use precious drinkable water to flush down toilets or water our backyards. So the opportunity area here is quite large. Think about solar panels on your roof. Think about reusing shower water for toilet flushing. There are technologies out there right now as people are, redoing their homes, they can use them. They're like, you install it, it takes your shower water, treats it mildly, and then you can flush your toilet with. And what happens here is if you repurpose and reuse water at your home at a smaller scale, what happens is you take less water out of the system. So your demand, again, reduces. So it's not just you conserving water, closing the faucet while you're brushing your teeth, or putting efficient fixtures in your home. It's actually repurposing the water that you use in your home in various ways and for different needs would reduce your baseline even more. Now, the same way that solar panels on people's roofs impacted and disrupted the power grid, these kind of solutions can potentially disrupt our water distribution grid. So there's a lot of thinking that needs to go into this and how it impacts our baseline and our demands in the long run. You might say, maybe this is sci-fi and who does this anyway? I'm just going to provide you some examples. This is the city of San Francisco has an ordinance for large buildings that are 100,000 square foot or larger to have actually an on-site reuse system. When this ordinance was put in place in 2012, I remember I would go to meetings and people would say, this only works in San Francisco. No one else is going to do this. I don't think at that time people anticipated we will experience 2 major droughts back to back. Now there are conversations around, can we have such ordinances for new construction, new commercial buildings across the state, and how can we do that? But also, I have a few other examples here. This one here is a brewery in San Francisco that's using recycling its water, and for the brewery, the one on the bottom right is a Microsoft campus that's doing a lot of recycling and reuse on site. And also, this is our Chase Center, which Golden State Warriors play at, and they actually reuse water. They capture stormwater and reuse water to flush toilets in that facility. So it can be done in many different scales. Now, as I said, water reuse can happen in broad scales. It can happen at building scale, at district scale. Potentially, multiple buildings can share reuse processes within a neighborhood, or it can happen as a satellite plant across the water, across the service area, or it can be a large treatment plant like the one that we have in the Bay Area, in the peninsula, the clean Silicon Valley clean water. So that can actually happen at every scale, and that the impact of all these different scales on demand are very different. So it is important to consider this and concentrate on this as we are thinking about what we want to build, what size, and in what way. Now, I'm going to come back to this later, but I want you to remember the scales that we discussed here, because it is important to think about that when we are thinking about rebuilding or building our future infrastructure and sort of redesigning our water infrastructure. Now, second question I have after reducing baseline for you is, what is an infrastructure? When we ask people what's infrastructure, they say roads and pipes and pumps and wastewater treatment plants. Often wastewater treatment plants and pipeline pumps don't come into play. A lot of people talk about energy infrastructure and roads and transportation. But if you think about it, yes, dams and road pipes and pumps and wastewater treatment plants all are part of our infrastructure. However, a lot of that infrastructure was designed to fight nature, to fight the limitations that are put on us by nature. However, the new mantra in our world is, how can we work with nature? How can we harness nature and the power of nature to enable us to build water security? And what you see at the bottom might not look so familiar to you, but a lot of them are wetlands and marshlands and different kind of ways of dealing with the impacts of climate change and green infrastructure that can potentially enhance our water supplies and prevent some of the impacts of or protect us against climate change. So working with nature should be part of our evolving urban water infrastructure or water infrastructure as a whole. But the problem with them is they're not singularly oriented. They have a lot of different benefits. When you talk about a marshland, or even you talk about a park as a green infrastructure, people don't think about the park as a water infrastructure. They think about it as a place that you go and have a social activity. But the reality is you can create, recharge ponds and create multi-purpose infrastructure within a park that can help us enhance our groundwater resources or protect our water sources from getting polluted, and a lot of different things that can happen in that. So nature-based solution can have a lot of different benefits, from water quality, air quality, water enhancement, community benefits, habitat and wildlife, all those things which can, but every one of the benefits that they have is quite different. The size and scale that they provide us these benefits for are smaller versus our conventional engineered solutions, right? So it's very different from building a dam, but if you have enough of this and aggregate it on top of each other, potentially you can achieve something greater than a single use. The problem with them is they're very complex to permit, because our 20th century model of institutions and laws and 19th century ones, they're very much singularly oriented. We have water supply, and then we have wastewater treatment, and then we have stormwater capture, and then we have road management, and we have energy sector. However, when you think about green and nature-based green infrastructure or natural infrastructure, they go across the board. So you need to permit them in different ways. You need to go to so many different entities to figure out how you can permit them. And that is very difficult and complex. So this fragmentation we have in water sector can be very limiting. But in a way, we have to think about these boundaries that are blurring across the sector and see how we can improve our permitting process. I want to make sure, is my connection good? Can you hear me well?
Yes, Newsha.
Okay, perfect. Just to give you an example on this, is that we did a study in the Bay Area to see what are the things that problems that people are facing when it comes to building green infrastructure, because a lot of utilities are interested in that, and actually state board and regional boards are very interested in that because they can provide multi benefits. This is actually one of the conversations we have when one construction company, they spend 4 years and $1 million to be able to get a permit to build a green infrastructure. And the construction work took $2 million and 8 months. So you can see the problem here, right? The fragmentation and the challenges that we're facing. While these solutions need to be part of the portfolio of solutions we are considering for water security and water reliability, it's sometimes very difficult to permit them because they get caught up in the fragmentation we have in the system and the way we permit the solutions and how many different hoops and loops people want to jump before they can build something like that. So they can easily stay on the conventional solutions that are out there and not implement these. To give you a little bit of a different look at this is when we think about water sector, they're sort of like we divide our water infrastructure into 3 buckets: wastewater, water supply, and drainage, or storm and flood water. As we look at the future, these are going to be blurry. They are going to blur into each other, and we want to use all of these water as a source of water to create water security. Again, permitting and fragmentation is quite real here, and we need to think about how we can actually overcome that challenge. Beyond reuse and recycling at every scale and demand management and nature-based solutions, there are other things that we can do, other alternative water supplies that we can consider. Stormwater and rainwater capture, that can happen at every scale. Again, you know, it can happen in your backyard, it can happen within a city as part of a cistern that we make, or can happen through the green infrastructure. Conjunctive use, which is this groundwater recharge that you see, you know, this is what we used to call it many years ago, which was about how do you manage your surface water reservoirs with groundwater reservoirs in a conjunctive way. So that's going to be more and more of a option as we are dealing with these major storms that are bringing a lot of water into our system, that we don't have a lot of space to store them, but we need them because we need to make sure we have water security in the long run. And we face more dry years. Desalination and brackish desalination in in different ways, and obviously brackish water desalination, wastewater treatment, desalination, all of that is also part of the option. Now, one thing that I wanted you to think about when we are talking about all these different options is that they don't come only in a centralized large scale top down. They come in different sizes, different scales. Sorry, excuse. A lingering cold that's not going away. Different scale, different sizes, and they're creating this circularity and sort of creating a circular economy for water. That is quite important if we want to become more water resilient in the years to come. They're also actually, as I said earlier, they're disrupting our model that we have. The top-down model that we have is being disrupted by these circularities, and we have to somehow figure out how we can manage our water distribution systems in the face of these new water sources that are coming in at different scales, in different entry points, and different forms and shapes. But the most important thing about this circular water and hybrid model is we would need to take less from the nature, and we would put less back into the environment, polluting less, demanding less, which means that we can potentially work more with that water. We can leave a lot more of it for the environment to protect the ecosystem, and also we can protect the ecosystem at the bottom part of our cycle. And as part of this, demand and supply are going to go hand in hand and need to be considered at the same time. Now, as we are transitioning, it's important to think about, what is needed beyond just putting infrastructure at every place. We need to think about what kind of management tools do we need? What kind of governance tools do we need? What kind of data do we need to gather? What kind of permitting do we need to, permitting model do we need to have? Are there different ways that we can manage across these systems more efficiently? And as part of that comes another form of infrastructure, which is data and information technology, which right now is not as much central when it comes to water utilities. They often don't have the resources to invest in data and information technology as an infrastructure, even though it is an infrastructure. So it makes them, it doesn't help them to, it sort of limits them in a way that they invest in those kind of solutions. The last piece of all this is thinking about social equity and diversification of the workforce. When we talk about social equity, often people think about race, but I think when we talk about diversity, we need to talk about diversity at various scales. For example, if utilities are going to grab more data, need to analyze more data to create more efficiency across the board and make sure they can manage their system better, we can't just hire engineers. We need to hire data scientists. If they want to make sure they have affordable water and they can do better with the demand data, we need to bring in social scientists. So we need to diversify our workforce within the water sector to include more than just civil engineers. And I'm not saying that those are the only people you see, but we need to do more, and we need to incorporate more people with different expertise as part of this transition. We need to bring diversify around genders, around race, also cultural diversity. People come in, water means different things to different people. There are cultural values that are put in on water. People need to make sure their cultural values are preserved and respected. So cultural diversity is also quite important. Before I go there, the last thing I want to say on the affordability and diversity and inclusion is the way we build in the future is also very much hinging upon what kind of solutions we have at the table, and having more diversity at the table from expertise, cultural, and gender can help us to consider a broader range of options rather than being very singular and trying to constantly sort of perpetuate what we have into the future. This will wrap it up. The 21st century water infrastructure model is going to be hybrid and singular, and that model need to be like focused on 5 very major questions. One is where, when, and how much water do we need? We need to have a smart grid that can track distributed production and consumption patterns, can inform the process of infrastructure investment and infrastructure building and design. So that is something that we need to sort of embrace as we are looking into the future. We need to think about what is infrastructure, more than hard and physical infrastructure. There's need to think about soft infrastructure such as data and decision support tools, information technology, also green and nature-based solution as a new infrastructure that we are incorporating into our infrastructure portfolio. And also human infrastructure, which is another very important part of this. The third question is, what kind of performance measures do we need to put in place to make sure the multi-benefits and cross-sectoral solutions, such as nature-based solutions and green infrastructure, can have a place in our portfolio of solutions that we are considering? And then what kind of new business model do we need to have to make sure this circularity and data-driven model and hybrid model is not going to break our water utilities, but it can help them evolve as our infrastructure model evolves? And then the last question is, who is at the table? Because that can very much impact how and where, how we are building, what we are building, where we are building, and what we are considering as viable solutions, and how we make sure that everything that we build is centered around affordability and access, rather than just benefiting a very handful of people in the community. And with that, I am done.
Thank you. Thank you very much, Newsha. That was terrific.
Sure.
I'm looking at the questions that we've got in the chat, and I want to kind of pull you back out of the very specific focus on the urban sector, because the 2 questions that I see in front of me are looking at how does agriculture fit into this? The lines that you're looking at for lower demand, and also kind of what changes and improvements are occurring within the largest groups of water users, both on the environmental side and on the urban. So on the agriculture. So it's really a step back looking at all of California. And what do you see as trends?
Absolutely. I think agriculture is a major part of this. One of the things I want to say is I often sort of try to focus on the fact that we are all one together. It's not ag and then urban. The same way as it's not environment and then urban. We're all in it together. We are the consumer of a lot of agricultural goods, and we are the waster of a lot of agricultural goods. So we can actually think about that at our end on how we can reduce waste and improve, because every product, everything that you put in the trash has a water and energy footprint. But also within the agriculture, we have to really rethink how we do land use management, because land use and water use are very much interlinked. And if we can't get a hold of how we manage land use across the board, we can't really make smart decisions around what kind of crops needs to grow in different part of the state, how much water do we use for those crops, can we become more efficient the way we use in the amount of water we are using. If some of these crops are grown in their natural environment, they may use a lot less. If they know how to become more efficient. How much irrigation do we do? Can we use smart solutions to create more efficiency in the agriculture? There are opportunities across the board in agriculture to become more efficient. And also remember, every drop of water that we use, regardless if it's used in the urban area or agriculture sector, it's polluted and needs to be treated. So reducing water use can extend the life of our water supplies and expand our water supplies. So trying to make sure we protect our water sources is also quite important. So again, using less water in agriculture can protect some of our pristine water sources that are right now being used, and potentially can protect our groundwater basins that are impacted by using pesticides and herbicides that are used in agriculture. So there's so many different dimensions that comes in when it comes to agriculture, and all those opportunities are available there. I think demand management, regardless of which sector you're looking at, should be first in line. How can we reduce the amount of water we use? That should be the first question we ask before we go to the next option. And I think going back to what you said, Marta, about environment, that also in a way reduces our dependence on the environment and help us leave more water in the environment for other species to use.
I think a related question to this is some of the opportunities for nature-based solutions within the agricultural sector. And there's been quite a bit, actually, as we look at the runoff coming this year and the potential for flooding, and this discussion about where can that water be constructively used to replenish groundwater basins.
Absolutely.
Down the state of California. And I guess I would never leave out your baseline. How are we doing demand management with respect to operation of those groundwater basins? But clearly there's some nature-based solutions that are very exciting.
Absolutely. I think that's a great example of nature-based solutions or green infrastructure, because in a way we are sort of marrying our using nature's natural processes to recharge our groundwater basin. Now, the question there is, going back to the 19th century laws, the way we manage our groundwater, it's quite archaic. We have been trying to improve it, but we are not fully there yet. So the question is, as we are recharging these groundwater basins, who owns that water, who has access to it? How can we make sure we protect that water rather than sort of providing more basically providing more opportunities for people to not make a lot of efficient decisions when it comes to water use and demand.
I have another question. Sarah writes, arguably, who is at the table will have a huge impact on the answers to all the questions you outlined for the 21st century water infrastructure model. What ideas do you have for promoting greater social equity and diversifying the workforce in California's current governance landscape? What are the best and easiest, most immediate inroads for new expertise and other forms of diversification? Great question, Sarah.
Great question. Look, I think we really have a lot of problem when it comes to hiring. A lot of water is not a very cool sector, or at least not perceived as that's what I should say. It's not perceived as a cool sector, so not a lot of young people are excited about coming to the water sector. They all are very much driven. However, it's, as Marta, you said at the beginning, water is where we meet climate. We just have, a lot of people, if they realize how much overlap there is with climate, addressing climate change with water sector, I think they all would be interested to come into the water sector. But we are sort of this out of sight, out of mind kind of a sector, and people don't really understand the value that this sector brings in. So we have a lot of hard time recruiting people to the sector. I would just say one example at SFUC, we really do try to kind of think about who do we reach, how do we recruit. We have put together different sort of apprenticeship programs that would take people from high schools or different colleges that are not necessarily, they don't necessarily have a direct link to us, to help give them an opportunity to come and train and learn about the sector and come in. We provide a lot of opportunities for them to work with within the city or the region on different projects. That way we can get a more diverse workforce. We try to kind of target a lot of the schools that are in places that are not necessarily always like a little bit in the disadvantaged areas, to make sure they have opportunities. And another beauty of water sector is there are all sort of jobs. It's not just engineering jobs, there are construction jobs, there are jobs that you can do with a high school diploma, and there are jobs you can do with a PhD. So it's quite diverse in kind of jobs that people can do. So we need to make sure we can train that. Now, not everybody that comes in ends up being at a table. Now, when we bring these people in, we need to make sure they get promoted. They do end up in leadership positions. They can bring in those voices to the table, and that's another part of the process that we have to work at. But look, I think thinking about leadership, who is at the leadership, who is at the helm, is very important, because good leaders promote good talent. Good leaders do promote various, a lot of different kind of people. They're not afraid of being challenged. They're not afraid of pushbacks, and that can create more space for others.
That's great. I want to take another question relating to your hybrid system, but I'm going to add a little information to the question. Because there's been so much focus for water agencies on being responsible for making sure everybody who could turn on their taps gets water. So obviously this drought was very challenging for many water agencies, because it was really one of the few situations where all of a sudden, Southern California is a great example, they couldn't guarantee that.
Yep.
And that is just anathema to the whole business model. So we see now a lot of conversation going on about, okay, we need to make additional investments in what I would call traditional infrastructure, dams and other 20th century type infrastructure. But then you can look at places where a lot of investments like this have been made, and they're also struggling now with the costs. So this is where I'm adding the little piece, because I've been reading a lot about articles from San Diego where people are very concerned about the investments that have been made on the supply side, and are concerned now that they can't afford the water. I mean, you even have people who probably normally you wouldn't expect to be concerned about the cost saying, why do I want to pay $500 or $600 a month to water my lawn? So from your perspective, as a leader in the water world, how do we walk the walk through this? Because the economic forces and our own conventional thinking is around supplies. We have to have more than enough so we can get through a drought. But if we build all that infrastructure, then the costs that are going to be imposed on our ratepayers will actually lead people to figure out ways to be more efficient and drop off the system.
Absolutely.
Style that.
Yeah, I think, I sort of touched on business model, but I didn't go deep into it. But if you think about water the way, because it was very much focused on providing service, as you mentioned, it's often sort of priced volumetrically. So as you use more water, you pay more for your water. So as people start saving more, somehow utilities, and also remember, a lot of the utilities are municipally owned utilities, right? So they're not making money. They just need to make sure they can people pay for their services and they receive, and the infrastructure that they depend on. So as you use less, somehow the utility needs to pay for the services and maintain the infrastructure. And that means that then they need to raise their rates to make sure they can cover that cost. because the cost doesn't go away. If you use a gallon of water or 100 gallons of water, you still need to maintain that pipe. They still need to maintain that dam. And they still need to think about how they need to pay the people who are working there and operate their system. So, so there's this conundrum right now going on with utilities, because every drought that comes, it's like a hammer. It hits on the water demand, it goes down, it doesn't bounce back up because people make structural changes, and the utilities then you need to go back and figure out what to do. Sometimes they basically just let go of a maintenance, and sometimes no, they have to raise their rates. So it's a very complex problem. The problem, actually, to your point, is, however, a lot of utilities are doubling down on those conventional solutions because that's what they know. Remember, if I have a centralized system, I don't want you. So imagine when you put a reuse in your home, if you reuse your shower water, your water use goes down by 30% all of a sudden. That's 30% less water that you take out of the utility. That means that utility is going to lose that much revenue, right? And they also lose control over the system because they don't know how much you generate, when you generate, would you need water from the system. So it's a lot more complexity. So they're not as excited and enthusiastic about these decentralized solutions. They like centralized solutions because it helps them to manage. They can have oversight over it. They know what comes in, what goes out. But what they are not realizing is that, very similar to solar panels on people's roofs, another drought may lead to more people embracing on-site reuse and gray water reuse. And as people embrace those things, like solar panels on people's roofs, the demand will go down, they want it or not. So they would have a lot of extra capacity that might not get used. Again, who has to pay for that? People who have stayed on the system. And often, who are those people who stay on the system? Potentially people who do not have the capacity to put on-site reuse system in their homes or build a gray water system. And that means that we create more inequities in the system by doing that. So that's why I think everything needs to start from baseline. And utilities are not looking at baseline as a way of rethinking and diversifying, because they don't want to lose control and they don't want to disrupt their business model. But their business model is being disrupted anyway, and they're just buying time. They're not really having the foresight. They're buying time for themselves.
I think this is called Welcome to the World of Climate Change and Climate Disruption.
Yes, absolutely. Absolutely. For sure.
I think we're at our 6 o'clock witching hour, so I'm going to turn it over to Jane. Thank you so much.
Thank you for having me.
Yes, thank you, Dr. Ajami. Thank you, Martha. Thank you all for joining us. This has been very, very good. Thank you so much. And everyone have a lovely evening. Thank you.
Thank you so much. Bye, everyone.